So all of this organic waste can be converted into biogas by a process called anaerobic digestion. So essentially, in the absence of oxygen, in the presence of anaerobic bacterial cultures, we convert it into biogas and biomanure, right? And this biogas is essentially a mixture of 60% methane and the rest is carbon dioxide. So this process itself is a net zero process or a carbon neutral process. So we are not adding any CO2 to the environment. So by using biogas, we are basically able to reduce the fossil fuel usage. The CO2 that is obtained can at a large scale can further be utilized for industrial uses. The biomanure, of course, is a very important part of the process. This is a completely closed process, and the return slurry that is obtained can either directly be used as a soil conditioner in the liquid form, or when we have large-scale biogas plants, we can further do solid liquid separate and use both the solid part as your, similar to how you would use compost, and also use the liquid part, which is still rich in nutrients for agriculture, organic farming, and so on. So we are talking about converting organic waste or biodegradable waste. We also call it wet waste, right? So this includes food waste from kitchens. It includes what we call as MSW, which is the municipal solid waste, which our municipalities collect. So, and then, the segregated wet waste from that. It also includes all kinds of cattle dung. It can also refer to agro waste. So there is a lot of rice straw and things like that people are aware of. That is a huge problem, as well as newer agro waste like Napier grass that people are actually cultivating for different reasons. So all of this organic waste can be converted into biogas by a process called anaerobic digestion. So essentially, in the absence of oxygen, in the presence of anaerobic bacterial cultures, we convert it into biogas and biomanure, right? And this biogas is essentially a mixture of 60% methane and the rest is carbon dioxide. So this process itself is a net zero process or a carbon neutral process. So we are not adding any CO2 to the environment, and we also get some traces of H2S, which we remove in the process. So ultimately, the biogas is a renewable fuel, which we are using for heating purposes. We can also convert this into green electricity. And another thing that a lot of people must have heard about now is CBG, or compressed biogas. So the 60% methane, which is in raw biogas, can be further upgraded into 94+% methane. And there we call it compressed biogas and CBG. And if we are pipelining it after purification, we call it PNG. So essentially, these are the renewable sources of energy that we are getting from our organic waste by the process of anaerobic digestion. The CBG or the PNG is further utilized either as a vehicular fuel or directly back into heating. So by using biogas, we are basically able to reduce the fossil fuel usage. The CO2 that is obtained can at a large scale can further be utilized for industrial uses. The biomanure, of course, is a very important part of the process. This is a completely closed process, and the return slurry that is obtained can either directly be used as a soil conditioner in the liquid form, or when we have large-scale biogas plants, we can further do solid liquid separate and use both the solid part as your, similar to how you would use compost, and also use the liquid part, which is still rich in nutrients for agriculture, organic farming, and so on. So a little bit more about biogas in terms of its unique property. It's a flexi fuel. And the reason we are able to use biogas to replace these fossil fuels is because it has an inherent calorific value due to the methane content. So just to give everybody an idea, 1 meter cube of biogas can replace around 0.42 kgs of CBG. It can also be converted to give 1 to 2.5 units of electricity or green electricity. It can be used to replace steam, ethanol, LPG, and so on. So what is unique about biogas is that it is a completely flexible use of renewable energy. No other fuel that is listed here can do all of these things, right? So we can replace 1 kg of CBG, which is equivalent to replacing 1 liter of petrol or 0.9 liter of diesel. And another interesting thing is that it also gives a better mileage. So the cost per kilometer is actually better than petrol or diesel. And as a renewable fuel, it's actually cleaner than any of these fuels as well, in terms of, the lack of emissions that are produced. So, now that everybody has understood all the technical parts, and the concept of how we produce biogas and how it is a flexible renewable source, I want to show you this simple diagram that my 7-year-old actually, when he understood what do we do, as a company and what are we trying to do in the environmental sector, he immediately drew this diagram, so it really struck me, and I have used this ever since, because the concept, if a 7-year-old can understand, then definitely we can make a change. And as adults, we can figure out that we have to adopt more and more renewable sources of energy. So here we are showing a biogas plant. So this is a circular economy model, essentially. And from the biogas plant, the biogas that is produced is used back for cooking or heating or the other applications that I was talking about. And from cooking is where you get the food waste, either your vegetable peels, your rejects, or unused cooked food, which goes back into the biogas plant. And then the biofertilizer or manure that is produced is going back in the soil as a soil conditioner and to put nutrients back into the soil, which is then used to produce food, right? Which is going back into the cooking. And other than this, the biogas plant also enables local manufacturers, so we do everything made in India. So in addition to circular economy, we are also promoting made in India economy. And the operations of the plant also enables hiring the local people, right? So waste warriors or women self-help groups and things like that. So it promotes a lot of things to enable our local economy. With that, I want to go to a little bit about what we are doing as a company, right? So how are we commercializing this? So we are a 35-year-old company who have been in EPC works. We are based out of Hyderabad, but we also have locations in Gujarat and in Delhi NCR, largely to support our plants all over India. Since we have 30 plus plants, as and when we are manufacturing and installing these plants, we are also adding offices and after-sales support in different locations. So we do the turnkey manufacturing. So we are basically manufacturing per our design these plants. And then we also do the installation, commissioning, and the sales, which can include operation and maintenance or annual maintenance contracts, depending on the customer needs. We have partnered with Council of Scientific and Industrial Research, Indian Institute of Chemical Technology, which is a Government of India organization. And so all of our plants are certified by them. Our plants can treat as low as 100 kg per day of waste. And these solutions are scalable, right? So we have been able to set up plants we can set up to 50 tons per day or more, but ideally, it makes sense to do plants which are distributive, decentralized, and where the waste available is already managed. So that's why I'm mentioning a scale up to 50 tons per day here. And we have, we are happy that we were able to get an Indo-US Space Center Award as well as the FABCI Excellence Award. And we have also executed several projects that have been funded with Department of Biotechnology and Department of Science and Technology by Government of India. And we are very proud and honored that our Bonpalli vegetable market plant, which I will show you in the subsequent slides, has been highlighted in our Honorable Prime Minister Modi ji's Mann Ki Baat. So that has caught a lot of eyeballs, and actually we need such kind of publicity because we feel that this field itself, lacks in awareness. Technologies are available, but we need to have more awareness that yes, these solutions are scalable and we have commercialized them and they are also sustainable. So why should we be using biogas or CBG or what, as I mentioned, Bio-PNG, right? What are all the advantages? So I touched upon a few of them, but broadly, we are solving 3 problems. One is the problem of organic waste, right? So India as a country generates more than 85,000 tons per day, and this number is growing of solid organic waste. And we actually have some rules and regulations in place also, that solid waste management rules of 2016, which says that all bulk waste generators who are producing more than 100 kg per day of waste should process their waste scientifically, either by composting or by biogas plants or what we call as biomethanation. So that is one issue, that we have a huge amount of waste that is currently, the only solution is, or part of the solution is going into landfills. And our landfills are also, again, you have to do it scientifically, and they are both pros and cons. We need landfills, but they also cause issues wherein they are close to the urban locations and they cause pollution of the water tables and the air as well. And space, of course, is limited. So we need to have different solutions to process this solid waste. The second is the energy needs of India, right? So the energy needs of India, 2/3 of our crude oil needs we are importing currently. About half of our natural gas requirement we are still importing, right? And it's only growing. The third is the soil quality. So India is predominantly into agriculture. Due to this overuse of soil and overuse of chemical fertilizers, the soil quality is also getting depleted. So by adding this biomanure that we get from biogas plants back into the soil, we are also enriching and adding the carbon back. So it's solving all these three problems while helping support our government goals, our SDG goals of reducing our fossil fuel imports. And of course, more and widespread adoption of renewable energy is what we wanted to do. And I talked about solid waste management rules as well. And finally, promoting organic farming through the use of this biomanure. So a little bit more on the issue, right? So specific to urban locations, we are trying to address the issue, because that is where the bulk of the waste is getting generated, right? So we have metro cities, we have second tier, 3-tier cities. We are growing rapidly, and so is our waste. So municipal solid waste, or MSW, we are targeting vegetable markets or Raithu bazaars where the waste is already available in a segregated manner. So before this waste gets collected and gets mixed up and goes to landfills, we want to set up the plants right there at the Raithu bazaars, and we have already done about 5 plants in this manner. Food waste from bulk waste generators. So any industry, right, be in a hospital or a hotel, a university campus, everybody pretty much eats food. Food is ubiquitous. So anybody that is cooking food in a bulk manner is going to produce food waste. And that is ultimately going to be an issue. Slaughterhouse waste is another example. Basically, even though a lot of the slaughterhouses have rendering units, where they are recycling a lot of the things, rendering it into different products, there's still the animal dung that is produced in huge quantities and again causes a lot of environmental issues. These are also close to the urban locations, so it causes issues to the people living nearby. So long-term dumping will obviously produce environmental hazards, and our space is limited. So we have to make sure that we send as little waste to the landfills as possible. In addition, there is a cost and logistics of waste transportation. So currently, as you all know, in every city, we have a large company or government municipality tying up with these companies who is collecting your waste on a day-to-day basis and then taking it to these landfills. So there's a cost to it, and everybody nowadays is paying also an amount for collecting and transporting this waste. Finally, I feel that there is the lack of awareness, regarding these technologies, be it composting, wherein, in a small scale, it is easily manageable, maybe up to 100 kg, or be it in biogas plants. There is a lack of awareness that yes, we can set up these plants in urban locations in a compact manner. They're easy to operate and maintain, and they are scientifically designed. So they do work in a long-term manner, more than, I would say, 15 years. And so if maintained properly, these plants work without any issues. So recently, people have definitely heard a lot of talk about green buildings, right? And reducing our energy requirements. There's green building councils and certifications. All of these things are coming up in a good manner. So this would be one more solution to add towards such goals. A lot of corporates are looking to comply with ESG goals, carbon credits, things like that. So hopefully this solution will address all of these things. So with that, I come to, what does this really look like? What is our commercial solution for urban locations? So this is what we called our in-house on-site waste manager for organic waste. So this entire plant we manufacture in-house. So I'll just talk to you a little bit about the process itself, right? So what you see here is a shredder. We have set up this particular plant inside a Raithu Bazaar here in Hyderabad. So first we shred the hard vegetable waste. This is waste which is not getting sold in the markets. And the farmers don't really have a supply chain to take this waste back. There's also a lack of cold storage facilities, which are very common. So what ends up happening is we have unsold vegetables, that at the end of the day get dumped and again have to be taken to the landfills. So what we've done is we have set up these plants inside the Raitu bazaars, and then the waste is first shredded, and then we have given this cabin, and we have a lot of our instrumentation inside so that it's safe, secure, and then the operator can work inside as well. Then we have a second size reduction step in which we add a little bit of water to make a waste slurry. This organic wet waste slurry is then going into an hydrolysis tank, which is shown here, an underground tank. And from here, we are pumping the slurry into what you see here in silver. This is a rectangular, modular biogas plant. This is a digester. So this is the heart of the process where the digestion is taking place and where our anaerobic bacteria is going to convert this wet waste into biogas and biofertilizer. So right now you can see that it is insulated here so that we maintain a mesophilic temperature. So 30 to 35 degrees is ideal for Indian conditions. And we have a lot of, our in-house proprietary design, which makes it a very efficient digester with very low OPEX and, very easy to maintain. So essentially what we end up getting is biogas in the headspace. And this biogas then gets stored in these intermediate balloons. So these are biogas storage balloons. So what this allows is that it gives you, whatever capacity you need in the kitchen. So in this case, we design around 1 day capacity of storage because this gas is continuously used in the kitchen and the waste is also coming on a daily basis. So it's a continuous process of biogas generation and utilization. And then we also see a pressure storage tank here. So this works in a way that the biogas, we compress it so that we can give it at a constant flow rate to the kitchen so that their experience is similar to that of cooking in a LPG environment. So this is essentially the process. And then what you see here is the return slurry that comes in this white return tank. 50% of the slurry is recycled back into the process to enrich the culture and to enrich the process. And the remaining 50% is used as a biofertilizer back into organic farming or landscaping. So this design that I just showed, we have made different waste handling capacities. So we start with 100 kg per day and we have set up a lot of plants of these different capacities, 300 kg per day, up to 3 tons per day. This is what I would call as small to mid-range of waste handling capacities. And right now, if you look around you, pretty much any university which has hostels is generating anywhere, one hostel will generate about 300 kg per day. Meena Madam mentioned Osmania University. The entire campus has multiple hostels and kitchens, and they are generating 2000 kg per day of waste. Any large hospital in Hyderabad, we have surveyed quite a few, is generating 1 ton to 3 tons of waste per day. So that is how, we came up with our product, that depending on the customer needs, we will give them appropriate size plant. And this is a completely closed, containerized plant, as you saw. So everything is, once you input the waste, it's completely closed. There is no noise, it's odorless. It has a very small and compact footprint. It's very customized to your requirement, whether you want to put it in an open space or inside a building, or it is spread out in your campus. We are customizing this based on the customer location. It's easy to operate, it's very safe, and we have enabled as well as remote process monitoring and data monitoring and things like that. So each of these capacities is directly giving you LPG savings or PNG savings, and that is what I'm showing here. So for example, a 1000 kg per day plant will save around 4 cylinders of LPG per day. Right? And the plant area is around 50 feet by 15 feet. So it's not a huge area that is required, and that can further be customized and be distributed as well. So I just want to show you what some of these plants look like. This is just a partial list of where we've set up in, which sectors we've set up in. So the plant here on the left is inside CVR College of Engineering. So this is waste coming from 2 of their kitchens, around 300 kg per day. And on the right is IT campus, Capgemini. So they also set up the plant. I think this is their 5th year of operation. So it's working very well. So from their canteen, campus waste, all of the wet waste comes here. And then they're able to utilize the gas back in the kitchen. We are actually doing the operation and maintenance for them as well. And since we are a very custom company, in this case, the customer wanted a vertical plant and the space was also limited. So we set up a 750 kg per day plant, and you can see the balloon storage is on top of another structure here. And so we are able to customize it based on the customer preference. And this is in Akshay Patra kitchen. We have about 13 plants in different Akshay Patra locations because they are in the, they are an NGO which is basically cooking midday meals for children. So what happens is the food that is prepared, whatever is not used, comes back, right? So there is always food waste that is generated. On the right is one of the locations in Akshay Patra in Gujarat. And these are 1 ton per day capacity plants. So again, on the left is 1000 kg per day plant in Ahmedabad for Akshay Patra. And on the right is the same capacity plant, but in a different configuration. So here you can see how the balloons are on top of the digester. So depending on the customer needs, we are able to give them the design that they want because the process and is essentially the same. So this is in Bhuj, Gujarat. And I'm very happy to say that recently we were able to get Amma's blessings and set up a plant, 2 ton capacity plant in Mata Amrita Manmayi Mat. So we're very happy to associate with that organization. This has been set up in the largest hospital that was inaugurated last year in Faridabad. And the waste from their entire campus is coming to the plant and it's getting utilized in 2 of their kitchens, right? So the plant is common to treat all of the waste, and then from the pressure tank, we are pipelining to 2 of their kitchens in the campus, and they are able to, save their LPG this way. So this was all, I would say, mid-size plants, and now I'm coming to large-scale plants. So when I say large-scale, it's more than 2 tons per day of waste handling capacity. So on the left, we have set up a plant in Hyderabad at Ramki, Jawahar Nagar. So as you know, Ramki is a waste collection company for Hyderabad. On their site, we had set up this plant is 3 tons per day. And here what was interesting is, since they did not have a kitchen, we converted the gas into electricity. So green electricity was being produced, and the fertilizer that was being produced was actually sent back for their composting, as well as the waste leachate that was being produced at the site from the landfill. We were also able to take that into our digester to further, process it and to reduce some of the harmful effects of the waste leak. So there was like an added application that we were able to demonstrate here. We also have done a 10 ton per day capacity plant for Bonpally vegetable market. So this has really been a very successful plant. It's the 5th year of operation right now. And, we are able to save both electricity, and then we are also pipelining the gas to their kitchen, the one that is inside the market yard. And 100% of their LPG is actually being replaced by biogas.